Well, we're reaching the end of these two fantastic 2 days. I will talk to you about this project that we have ongoing that's called BRACE2, which stands for Bridge Rapid Assessment Center for Extreme Events. So I'll talk about a few high-level points, and then I'll pass it on to Claudio Perez, who's actually doing the real work. But before I start, I want to thank Chris Traina and Sharon Yen for pushing us to develop a useful product. And also thanks go to Hamid Haddari from CGS, because as Ritwik said, and also Jack alluded to that, the fuel of all these things is the data. And CGS own the data. All what we're trying to do is to make use of the data, such that CGS and other entities can go and collect more data. And people can sit down and trash machine learning and say we have to only use physics-based and all that. I think that's empty talk, because the only way to deal with these big data is to machine them. You know, you got to put them in the washing machine and get some clean clothes out of it. And when the data is very big, these are fantastic tools. Of course, we don't have to use them blindly. And there are ways, Jack mentioned explainable AI and all these things, and they do exist. We just need to read the papers and learn about them. So the idea of CNN being a black box and all that, I'm not buying this. So, and you cannot convince me otherwise. Anyway, so I thank Hamid for sharing the data with us and giving us the opportunity to have access to this data in real time. And then, of course, a long list of peer students, postdocs, and researchers who are working on BRACE2. I'm only putting 3 names here because the list is long, but these are the 3 people who have a lot of persistence and they stay all the time on the program. And then also our partners, Ramin Mu'tamid in UNR, who's also providing us with good tools that involve not just the superstructure, but also the substructure. So a quick overview, and then I pass it on to Claudio. As I said, the whole idea is to develop a data and simulation framework for real-time rapid, if we want to do it in real time, or near real time if you want to do it comprehensively. Because we know if you're going to do something comprehensive, you're going to use a model, a large model, it's going to take time to be able to execute it. So that's where the distinction is. And this is done for bridges who have instruments. And we have to do that because I do experiments in the lab, and there is nothing in comparison with getting data from a real bridge in comparison with what you get in the lab. In the lab, we solve a boundary value problem with highly idealized boundary. That's not what exists in the field. And if we have these sensors in the bridges or in the buildings or in the hospitals, we better make complete use of them so it can direct what we do in terms of simulation or more testing. So we basically want to take advantage of that, and that's what BRACE2 is about. This map here, that if you go to our website, which you cannot access yet, only Caltrans folks can access it because we're not sharing the password yet until we finish our work. You see all these gray balloons, which are every instrumented bridge in the CESMD database. And we have access to all the data, and we can manipulate this data. And then if you look more carefully, you see some of these balloons are blue. The blue ones are the ones we have a so-called partial digital twin of, which means we can take the data, channel them through some computational model, whether it's data-driven or physics-based, to learn something from the data. And there is only one bridge that comes in a tan color, which is the one that has the full digital twin. When we started this project, we only picked 5 bridges as the phase 1 of BRACE 2. So these 5 bridges are part of these blue balloons, and the one tan color or orange color, whatever the color is actually the centerpiece of the BRACE 2 at the moment. That's our playground, which is this Hayward Bridge. This bridge has 20 sensors in the superstructure, has 12 sensors in its east geotech array. Thanks to CGS, we have real-time access to this data. Anything that happened to this bridge, a heavy truck passes by that triggers the sensors, the peer server gets the data in real time. And then Claudio does his magic to learn something about this data. So what goes in parallel with the data is a physics-based model. We try to exercise everything we learn about modeling structures, the abutments, the in-span hinges, the columns, linear model, nonlinear model, and also the soil structure interaction with the help of our friends in UNR. So in summary, we have a lot of data coming in. When we started this work back in 2021, this little histogram here, it shows the data that has been coming to our server so far. Oops, I don't know what I clicked here. Should I make this big again? Yeah, okay, good. Yeah. Okay, this mouse is a little, okay. So this shows the data we had access in real time, and this shows some of the physical models that we use to learn something about this instrumented bridge, and then also putting this data through a system ID so we can get an idea about its vibration characteristics, its damping properties, and so on, which helps in guiding what is the health of this bridge. So here, this is my single slide about results that show 2 events. One of them that took place before BRACE 2 started, so this took place in 2018, and one after BRACE 2 started, this took place in 2021, one in Berkeley, one in San Lorenzo. These are small shaking, and what you see here are different methods of system ID with the different color bars, and the 3 sets are for the 3 first modes of vibration of this bridge. That's the Hayward Bridge. And you see the consistency between before and after the data sets that we get just from the CESMD database by downloading it, or the data that was streamed to us, and then we applied the same algorithms to it. Of course, the bridge, nothing happened to it between 2018 and 2021, so that's why results are very repetitive. So I'll pass it on to Claudio to talk about some more details about the platform related to the predictors that we compute and a little bit of advances that he's working on.